Welcome back. This is 3/31/2020 homework review request. So our first problem is page 568, number 12. And here is number 12. They want to know, write a rule. Triangle A prime, B prime, C prime is the image of triangle ABC after a translation. A translation is when you shift something left, right, up, or down, or a combination of those. Write a rule for this translation, then verify that the translation is isometry. An isometry is when you're moving left, right, up, or down. You are not dilating it. When you dilate something, it's like when you dilate your eyes at the eye doctor. They put the drops in your eyes, and it makes your pupil get very big. It enlarges it so that the doctor can look into your eye and see if there's any abnormalities. So a dilation is going to make something bigger or smaller. It reduces it, or it enlarges it, right? A reduction or enlargement is a dilation, where a translation is just left, right, up, or down. A rotation is just rotating it about a point. It's just moving in a circular motion. It stays the same size, same shape. And a reflection also stays same size, same shape. It's just reflected over a line. So to verify that it's an isometry, all sides are equal. The AB is equal to A prime, B prime, BC is equal to B prime, C prime, AC is equal to A prime, C prime. So if we're looking here, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Here we have up 3 over 1, up 3 over 1. So if I had 3 squared is 9, 1 squared is 1, so that's square root of 10 right here, square root of 10 right here. Here we have up 1, 2, 3 over 1, 2, 3. 3, 3, 3 rad 2, right? 3, 3, 3 rad 2. That's like a little 45, 45, 90 if I was doing a quick Pythagorean theorem. So we know that these are equal, and these are equal. So if they are just translated, all sides should be equal, all angles should be congruent, and it's just shifted. So what is this translation? Well, we're going from our original, from our pre-image, to our image. We know which one's the image because it has the apostrophe for prime. So we're going right 1, 2, 3, up 1. Right 1, 2, 3, up 1. Right 1, 2, 3, up 1. So this is just simply xy becomes x plus 3, y plus 1. We're shifting right 3, 1, 2, 3, up 1. X plus 3, comma, y plus 1. If I take my x coordinate and I add 3 to it, and my y coordinate and I add 1 to it, it's going to give me my prime. So I can verify this. I'm at 1, 2, 3, 4, 5, 6, negative 6, 1, 2, 3, 4, negative 6, negative 4. Once I apply the rule, negative 6 plus 3, negative 4 plus 1, I'd have negative 3, negative 3. Let's verify that that's where my A prime is. Negative 1, 2, 3, negative 1, 2, 3. And that's where my A prime is, my image of my A. So it checks out. Next problem. Next request was page 569, number 18. Use the point P at number 18. P, negative 3, 6. Find the component form and the vector that describes the translation to P prime. We're at negative 3, 1, 2, 3, 4, 5, 6. And we're going to 0, 1. So we're at negative 3, 6, and we're going to 0, 1. We are going x plus 1, 2, 3. Y minus, we're going from a height of 6 to a height of 1. We're subtracting 5, right? If I was doing a rule, my rule would look like this. So our component form, we literally just write this without this format. So we take our plus 3 and our minus 5, and here is our component form. Okay? Next. Our next request was 21. 21, we have p prime at -3, -5, and we had p at -3, 6. All right, so if we're going from p, our pre-image, to this. All right, so we were at 1, 2, 3, -3, 1, 2, 3, 4, 5, 6. We're at -3, 6. That's our original. Now we're at -3, 1, 2, 3, 4, 5, -5. That is our image. So we went left, right, nothing. So if I was going to write a rule, my x stays the same. My y value, I have to subtract. I'm at a height of 6. Now I'm at a height of -5. That's 6 plus 5 more. That's 11. Y minus 11. So in our component form, we have 0. We did nothing, and then we subtracted 11. Our next request is number 30. Translation A maps AY to A plus N, comma, Y plus M. The translation B maps XY to X plus S, Y plus T. Translated point using translation A, then translation B. Write a rule for the final image. Okay. So my XY, first I'm doing this, then I'm doing this. So I'm really going to have X plus N plus S, comma, Y plus M plus T, because I'm going to do both of these. So I have to put them together. Translated point using translation B, then translation A. So I'm doing B first and then A. So X plus S plus N, Y plus T plus M. You're going to get the same thing. Compare the rules. They're the same because addition is commutative. The order does not matter. 570, number 33. Designers can use computers to make patterns in fabrics or floors. On the computer, a copy of a design in rectangle A is used to cover the entire floor. The translation XY becomes X plus 3, comma, Y maps rectangle A to rectangle B. Use the coordinate notation to describe the translations that map A to C, D, E, and F. Okay, so going A to C. So, these are all the same size. They're all equal rectangles. So I'm going from A to C. I'm going over, this point went over 3. And then it went over 3 more. So it's really going over 6. X plus 6. Y stays the same. X plus 6, comma, Y. If I'm moving A to D, this point's becoming here. So I'm just going, my X stays the same, and I'm shifting it down 4. X, comma, Y minus 4. For if I'm taking rectangle A and I'm shifting it to rectangle E, I'm going down 4. This point right here is going down 4 and then over 3. So I'm going X plus 3, right? X plus 3, Y minus 4. If I'm changing rectangle A to rectangle F, I'm going over 3, 6, X plus 6, Y minus 4. And my A would be here, A prime. 42. Use the equation 2x plus y equals 4. Graph the line and its image after a translation, x minus 5, y plus 4. What is the equation of the image of the line? Okay, well, let's break out a piece of graph paper. Okay, so originally we have 2x plus y equals 4 without using a graph. Ooh, so this one says without using a graph, so I'm not going to break out the graph paper, I just have to think. So, what number are we on? We're on 42, okay. without using a graph. So I'm going to rearrange this to y equals negative 2x plus 4. And I'm just going to think about that. So I have a slope of negative 2, a negative slope, and I'm starting at a height of 4. And then they want me to translate. So my y-intercept of 4 is going to move. My y-intercept of 4 is moving left 5. So instead of being at 0, 4, my 0, 4 is going left 5, and it's going up 4. Negative 5, comma 8. This is my new point. Okay, this is my x, this is my y after I've translated it with this component form. So I know that I have this point, and I know that I have a slope of negative 2. So my equation, y equals mx plus b. 10 plus what equals 8. Subtract 10 from both sides, negative 2 equals b. Y equals mx plus b, and that is my new equation. Y equals 2x, y equals negative 2x minus 2. And they put it in standard form, so all you're doing to put it into standard form is just adding 2x to both sides. 2x plus y equals negative 2. That is an equivalent equation. That's in standard form. That's in slope-intercept form. Compare the line and its image. What are the slopes? They have the same slope. Their slopes are negative 2. What are the y-intercepts? Your y-intercept was negative 2. And then on the new one, your y-intercept is... on your original, your y-intercept was 4, and on your image, your y-intercept is negative 2. Okay? And your x-intercepts, that's when y equals 0. Your x-intercepts are when y equals 0. So on your original, your x-intercept was, I'm using the cover-up method, 4 divided by 2 is 2, x-intercept of 2. And on your image, your x-intercept is negative 1, because you divide by 2 on both sides, you get x equals negative 1. Okay? Your x-intercept is when y is 0, cover-up method. And then C is the exact same thing. You're just applying a different rule. So once again, put it into y equals mx plus b. And then think about what happens to that y-intercept when you apply, when you add 2 to your x and subtract negative 6 from your y. And then use your slope and your point to put it back into an equation. All right, so our next request is page 577, number 22. On number 22, we are multiplying. So we have 4, 8, negative 1, and we have 3, 2, and 5. All right. So we are using, we go like an L, right? So we have a 1 by 3, and here we have a 3 by 1. The middle terms have to be the same for them to cancel out, and we know that our answer is going to be a 1 by 1. If the middle terms don't cancel out, then it cannot be multiplied. So we need one answer. This is row 1, column 1. So I'm using row 1 with column 1. 4 times 3 is 12. 8 times 2 is 16. Negative 1 times 5 is negative 5. Okay? So we have to add these up, right? We're doing, I'm going to write it all out for you guys. So we had 4 times 3 plus 8 times 2 plus negative 1 times 5. 12 plus 16 plus negative 5. Well, 16 minus 5 is 11, and 11 plus 12 is 23. So our answer, it's one number, and that one number is 23. It's written just like this. And then our very last request of the evening is number 23. Number 23 is also multiplication. 9, 1, 2, 8, negative 1, 4. And then we have 4, 0, 1. Okay, so on here, we have a 2 by 3 and a 3 by 1. Our 3's cancel each other out, leaving us with a 2 by 1 for my answer. 2 down, 1 across. So 2 down, 1 across. So we just have 2 numbers. So our first number, this one is going to be row 1, column 1. Row 1 with column 1. So that is going to be 9 times 4 plus 1 times 0 plus 2 times 1. 9 times 4 plus 1 times 0 plus 2 times 1. 9 times 4 is 36 plus 0 plus 2. That's going to give me 38. Okay? And then for our other one, we have row 2, column 1. Row 2 with column 1. So for that, we have 8 times 4 plus negative 1 times 0 plus 4 times 1. 32 plus 0 plus 4. 36. So our final answer, 38, 36. And that is how you do matrix multiplication. I hope you enjoyed tonight's review. Please like and subscribe and have a fantastic day.